division algorithm. We have already discussed in our early lecture series, but here we are just recalling and going to the advanced level of the application of Euclidean and division algorithm. When the concept of division is first introduced in primary school, quotients and remainders are used. We begin with a simple picture that should be familiar to the reader, and we explored its relevance. Like you can see, this is divisor, this is quotient, this is dividend, and this is the remainder. So this is very basic, and you can see 487 is when divided by 32, then 15 is the quotient and 7 is the remainder. So this is very basic, but here we are going to see something like the process above used to divide 487 by 32 can be formalized through the division algorithm. And if we look at this theorem, for natural numbers a, b, we use the division algorithm to determine a quotient and remainder qr such that a equals bq plus r. Then the greatest common divisor of ab equals greatest common divisor of br. We have already discussed the method of finding greatest common divisor and least common multiple. So here we are just trying to apply these concepts for the various, the applications of the theorem, and in many problems. Like to prove this theorem, first of all, here the set of common divisor between a and b is the same as the set of common divisors between b and r. If d is a common divisor of a and b, then since d divides both a and b, d divides all linear combinations of a and b. Therefore d divides a minus bq equals r, meaning that d is also a common divisor of b and r. And conversely, if d is a common divisor of b and r, then d is a common divisor of all linear combinations of b and r. Therefore d divides bq plus r equals a, and hence d is also a common divisor of a and b. But we have established that the two sets of common divisors are equivalent, so therefore the greatest common divisor must be equivalent. This is important. And there is a corollary of Euclidean algorithm for two natural numbers a and b. If a is greater than b, to find greatest common divisor of a and b, we use the division algorithm repeatedly. This is already we have done where we were discussing the method of finding greatest common divisor of the given numbers. So here, suppose a is greater than b, so we have to divide a by b. So a is the greater number, so we have to write a in terms of b q1 plus r1. Same here, again b divided by the r1, and here b equals r1 q2 plus r2. Same here, this process will continue, and we have the greatest common divisor of a and b equals greatest common divisor of b r1 equals greatest common divisor of r1 r2, and dot dot equals greatest common divisor of rn minus 1 rn equals rn. So the second last term, until the remainder is not 0, we have to continue this process. For each of the equations above, simply use Euclidean algorithm theorem to arrive the quality chain.